Okay, so I'm going to do another example of doing a Lewis structure for diatomic molecules, just because I think the more practice you get with this, especially when you need double bonds and stuff, the better. So we're asked to draw the Lewis structure for a carbon monosulfide molecule. So first of all, we've got to count the number of valence electrons. So we've got carbon, which is 4 valence electrons, and we got sulfur, which is in group 16, so has 6 valence electrons. If you're still a bit like, ooh, not sure about that, just remember carbon is 2s2, 2p2. So add those 2 and 2 electrons together, you get 4. Sulfur would be 3s2, 3p4. So add the 2s electrons and the 4p electrons together, you get 6 total valence electrons. That's where that's coming from. And there's no charge on here. So we get a total of 10, if I can type, 10 valence electrons. So then which atom is going to be the central atom? It's got to be the carbon, okay, because it's got the highest bonding capacity. Again, if you are like not sure about this whole bonding capacity thing, just quickly draw the Lewis structure, okay? So carbon has got 4 valence electrons, sorry, the Lewis symbol, right? So the Lewis symbol for carbon would be this, and for sulfur would be 3, 4, 5, 6. Just do it this way around because it's easier. So in terms of spots where they want to form bonds, carbon has got 1, 2, 3, 4 places where it's going to want to share electrons and form bonds, and sulfur's only got 2. So carbon's got a bonding capacity of 4, sulfur's got a bonding capacity of 2. So carbon is going to want to be the central atom. So then we've decided on our central atom, so we are going to make a rudimentary structure where carbon is bonded to sulfur, like so. Carbon's the central atom, and then we are going to complete the octet of the lucky peripheral atom, which is sulfur, and then we're going to do a little quick count up and see where we're at, okay? Okay, so how many electrons do we have in our structure? We've got 2, 4, 6, which is taking care of all those lone pairs around the sulfur, and then 8 for the carbon. So we've got 8 valence electrons. That's not good. We need to have 10. So then we can start adding lone pairs of electrons to the central atom, which would be carbon. So carbon gets 1 lone pair, which is nice if you're carbon. So now we should have our 10 valence electrons. All right, happy days. So once we've got our 10 valence electrons, does carbon have an octet? No, carbon has got 1 lone pair plus 1 pair of bonding electrons, so it's only got 4. So that's sad, isn't it? Okay, sad carbon. Okay, so what we're going to need to do is convert lone pairs to bonding pairs so they're shared. And seeing as the sulfur has got more of those lone pairs, I would say that we would take lone pairs first from the sulfur. In fact, we're going to want to do that twice because carbon's only got 4 electrons around it. It's going to want 8. So we're going to have to take 1 lone pair, we'll get it to 6, and then another lone pair, we'll get it to 8 electrons by sharing. We have to share because we can't just add electrons because we've already hit our limit of 10 valence electrons. So if I redraw that, so we've got carbon, we got sulfur, okay? So carbon still has its same lone pair of electrons that it had to start with. 2 of sulfur's lone pairs are now shared in the bond, so it's only got 1 lone pair remaining. And then we should have a triple bond, okay? Because we already had a single carbon-sulfur bond, and one of the lone pairs has made this bonding pair, and the other lone pair has made that one. So that would be my carbon monosulfide molecule.